This is section 7.1, Power Functions and Function Operations. The homework for 7.1 is 1 through 21 in the homework packet. Suppose I give you two functions, f of x equals 3x minus 8, and I give you a second function, g of x equals 2x plus 7, and I ask you to find f plus g of x. Well, let's first talk about what this means. This actually is notation for add the two functions together. And it turns out that there's no standard notation for add two functions together. You can see f plus g of x. You can see f of x plus g of x. And sometimes you can even see f plus g. This is all notation, different notation for the exact same thing. And it's telling you to add those two functions together. So let's take our f function first. We have 3x minus 8. And we need to add the g function, add our g function, which is 2x plus 7. The nice thing about adding is that we can just drop the parentheses. 3x minus 8 plus 2x plus 7, and combine like terms. So we have the 3x, we have the 2x, we're going to combine them. We have the negative 8 and the 7, we're going to add those together. And we would say f plus g of x is equal to 5x minus 1. Example 2, I'm going to have you do on your own. F minus g of x. Again, there's different notation. So we could have f of x minus g of x, or we could have f minus g, and again, that all means the same thing. So I want to subtract the two functions. Again, start with parentheses. Subtract parentheses. 3x plus 1. It is really important you put parentheses when we subtract. With the addition, we can drop the parentheses. On the other hand, if we're subtracting, we have to distribute that imaginary negative, not imaginary, it's not an imaginary number, but this negative 1 that we don't normally write, you do have to distribute that to the 3x plus 1. So the 4x minus 2, there's no negative in front of this, so I can just drop the parentheses on that one. But on the second one, I do have to distribute. So negative 1 times 3x will give me negative 3x, and negative 1 times 1 will give me negative 1. Now I combine like terms, x minus 3, so f minus g is equal to x minus 3. Example 4, I want you to do on your own. Let's take a look at example 5. Example 5, we have f divided by g of x. So we're going to take and it does say the f function has to go on top. So we're going to take our f function, put it on top. We have 12x plus 10, and the g function goes on the bottom, 3x plus 5. Most students are tempted to cancel. They see the 5 goes into 10, they want to cancel that out. So they're like, 5 goes into 10 twice. Unfortunately, that does not work. You cannot do 5 into 10. You can't do 3x into 12x. That doesn't work either. The reason why is because of this plus sign. Because of the plus sign, the rules are different. So, turns out you cannot simplify this function at all, and your answer 12x plus 10 over 3x plus 5. Let's take a look at example 6. Again, we have f divided by g. So my f function has to go on top, and my g function on the bottom. Now with this one you can actually simplify. There is no plus over here, so you don't have to worry about that. Okay. So I do know that 4 goes into 16 4 times. So right now I am currently for x to the 4th divided by x. Now if you recall the rules for exponents, that's great. You can do the rules for exponents. If you don't remember the rules for exponents, remember x to the 4th is shorthand for x times x times x times x. And you know that x divided by x will give you 1. And what we have left over, 4x to the 3rd. Example 7, we have f times g of x. So f times g. So we need our 7x to the 6th, parentheses, 2x to the 10th. When we're multiplying, notice again there's no plus in here, so I don't have to distribute. I don't have to worry about distributing. What I do need to do is multiply the constants together. 7 times 2 is 14. I also have to multiply the x's. Okay. Now again, rules for exponents. You could remember the rules for exponents. But think about what's going on here. We have x to the 6th. What that means is I'm going to have x times x 6 times. And this one is x to the 10th. So that means x 10 times. So I could write all of these, 1, 2, 3, 4, 5, 6. And then I could write 10 more. 1, 2, 3, 5, 6, 7, 8, 9, 10. Ran out of room. Or you could do a shortcut and say, oh, I've got 6 of them here, I've got 10 of them there. Altogether, I have 16 x's being multiplied. Let's take a look at example 8. We have f times g, again, of x. And let's put it in parentheses again. 2x plus 5. Generally, when we want to multiply, we put it in parentheses. So you need parentheses when you are subtracting. You need parentheses when you're multiplying. So I have x minus 8 and I have 2x plus 5. I've got two terms. These are binomials. Remember when you multiply binomials, it's been a while since we've done this, but when we multiply binomials, you can use the box method. So 2x and 5. So x times 2x gives you 2x squared. And x times 5 is 5x. Negative 8 times 2x is negative 16x. And negative 40. So that when you combine like terms, you have 2x squared. You add the x's together. Negative 16x plus 5x gives you negative 11x minus 40. F times g. Example 9. Now this one's different. Notice that's a 2, and that's a 2, and that's a 2. It's not an x anymore. So this we do a little bit differently. So we have f times g of 2. Now let's think about that notation again. I have f times g of 2. Another way of writing that is f of 2 times g of 2, f of 2 times g of 2. If we go back up to the original problem, we see that f of 2 is equal to 20. So I'm going to replace my f of 2 with 20. And my g of 2, you go back up here, g of 2 is equal to 4. I'm going to replace g of 2 with 4. And so 20 times 4 is 80. So f times g of 2 is 80. Similar example, only this time we have f divided by g. So f divided by g, we take our f of 8, which is 5, and our g of 8, which is 15. You do notice that 5 does not go, or 15 does not go into 5 evenly, but it does reduce. I do want you to reduce all your fractions. 5 goes into 5 once, 5 goes into 15 3 times, so your answer is 1/3. There is another operation called function composition. I will talk about that in the second video. So that's it for the first video.